This is Fenchurch. So we're going to talk to you today about how we use machine learning to generate lots of metadata about our content. And metadata is just data about another piece of data that describes it. It's pretty simple, really. Fenchurch is what the product is called, and we kind of have a lofty ambition for this, which is that we want to create the best described audio in the world. Here's the problem that we're trying to solve. As we just said, every single hour, the BBC is producing 57 hours of radio. There is absolutely stacks of this stuff, loads and loads of rich and valuable content that we are producing. The problem is that it is sparsely described with metadata at the moment. We can't tell you an awful lot about this content beyond some fairly basic information. So there is loads of it, but it's really difficult to work out what's where, what it's all about. We're pretty sure there's some really good stuff in here somewhere. I don't know where. It might be over here somewhere, or maybe it's over there. I'm not quite sure, but there's lots of good stuff there. We just got to find it. So with this lack of metadata, the real challenge for us is how then we curate personal experiences in sounds, and how we make radio searchable, how we produce great recommendations, particularly for listeners who are under 35, who might be new to some of the kind of content that we're producing. So here's a particular example of what we're talking about. We've been working with the Jeremy Vine team for the past few weeks. And so this is a program on Radio 2, one of the most popular national networks. Jeremy Vine's show is from 12 till 2 every day, mixture of music and talk and phone-ins. And what we know about this program, before we've run this through Fenchurch, is the 8 or 9 words that we've got there. We know, half of them just tell us where the program is from. We know that it was an OB from Belfast, and then we know that they were talking about the general election. But other than that, we can't tell you a huge amount about this unless you happen to be listening. What we end up with at the end of the program, the technical term for this is a big blob of audio. We've got a big blob of audio for all the hard work that the production team put into making this. This is the problem that we're trying to solve. So we've built Fenchurch to do that, and Fenchurch does 3 things. It segments live radio, it transcribes it, and it tags it. We're going to walk through each of those in turn. So firstly, the segmentation. We listen to signals from the radio studio during TX to identify where there is a speech segment, where there's a music segment, where a trail is being played. And in near real time, we identify these. This big blob of audio, we're now able to chop up into segments. In red here, you see all of the speech segments for this particular episode of Jeremy Vine from a couple of weeks ago. And we do this for a couple of reasons. Firstly, because now you might not want to listen to the entire 2 hours of this episode. But if we chop the thing up, we've now got chunks of a program that have some value in their own right that we might want to serve up to the audience independent of the rest of the program. And then secondly, for some of the machine learning processes that follow, then chopping up the audio in this way makes it slightly easier to process afterwards. So we've done step 1, we've segmented it. The second step then is to transcribe it. And every one of these speech segments that we've identified, we then put through speech to text, and we generate a transcript from them. And here are some of the transcripts of what was said in this particular episode of Jeremy Vine. One thing you'll notice is that it's not 100% accurate, because we don't expect the technology to be at the moment. But now, at this point, we begin to understand pretty much every single word that was said in our radio program, all 2 hours of it. So already we're moving on in our understanding. The third step then of the 3 is tagging. We segment, we transcribe, and now we need to tag it. And I can step back from this particular episode a bit and just talk to you a little more about what tagging means. And in the BBC, there are a few different types of tags that we are looking at attaching to our content. And here are 3 categories that we're interested in. So we might tag a bit of content for the intended audience. Who's this meant to be for? Who's meant to be listening? Hopefully the under 35s. And we might tag it for the editorial tone, the tone of the piece. Or we can say, well, thematically, what was the thing about? Or what were the things that were mentioned? So, for example, this talk, we might say this talk is about machine learning, or this talk is about metadata. We can break that down even further, and within intended audience, we might split that up by location or age. And in tone, fairly simplistically, we might want to describe a bit of content as either happy or sad, and about or mentions. We can break it down even further. We might say, well, a piece of content, in terms of its location, we're aiming at a national audience, or this bit of content is intended for a regional audience. In tone, there are all kinds of vocabularies we can use to describe a piece of content. And in mentions, then we can pick out the people and the places and the organizations that are mentioned in a piece of content. The real value for us comes when you start to join these bits of metadata up. You join the dots. So we can say a national bit of content that is aimed at the under 35s, that has a light-hearted tone to it, and mentions the topic of it, say, is drug use. If we can understand that about a bit of content, then we can go and find other bits of content that are about similar things, or that people who liked that also liked. So we join the dots between the bit of content. And what we're going to do now is you are going to do some of this tagging for us, because we have built a product to do this, but it took us ages and it was really hard, and people do this really well as well. So you're going to do a bit of this for us. We're going to crowdsource the tagging so that we don't have to do it. And what you're going to focus on are these kind of tags here. So focus on this side of the screen, the abouts and the mentions. And we are going to play a 30-second clip of audio. And you need to listen to that, and you're going to tag it. And you're either going to tag it for to tell us what it is about, what's the topic or the theme of the content, or you're going to pick out what is mentioned, just everything that is mentioned in it. So if you are in the middle of the room, you are going to tell me what this clip of audio is about. And if you're on the flanks, then you are just going to pick out everything that is mentioned. Okay? About, mentioned. 30 seconds of audio. You can listen to it and do this in your heads. And then at the end, Chris will invite you to shout out and tell us what on earth this stuff's about, because we don't know. Okay, here's the audio.
Always good to get context when you come here, so our reporter Tim Johns will start by giving us the portrait of the city and its rich history.
Belfast is both the capital of and the largest city in Northern Ireland. With a population of more than 300,000, it nestles near the east coast. The city centre's home to the Cathedral Quarter, with its Victorian music venues, the Grand Opera House and the Ulster Hall. From here, follow the river north and you'll find Belfast's thriving port. It's at this point I have no choice but to play this music.
Cool, okay. Around the outsides, mentions first. Here first, shout out.
Cathedral Quarter.
Cathedral Quarter, Tim Johns, nice. Any more? Northern Ireland? Belfast. Over here. Ulster Hall. Titanic, nice. City? What's it? A city. Just the word city, as in the concept of a city. Okay, yep. Cool. Any more? Any more mentions? Okay, and the more difficult one, topics. What is the theme of that?
What is it about?
Belfast. Any others? Travel tourism. Travel tourism, okay. Well, valiant effort. Shall we see?
Yeah, you can't do it as well as we can, so we win. I think you pretty much got it. These are just our go at this, by the way, not the machine. We're just comparing two humans now. But you might, yes, is it about Belfast, Northern Ireland? Maybe it's about tourism, because someone's taking us around a city, and all the things that are mentioned, then you pick them out. So you've actually done very well there. I wasn't expecting that to go so well.
No one,
That's
no
good.
one got Brexit, though. I don't know. I mean, surely that was obvious.
Everything's about Brexit, so you always have to say Brexit. That's great. The problem is that we are producing 57 hours of radio whilst we're doing this talk, so nobody can leave and go to the pub. You all now have to stay here and just keep doing this every day, every hour of every day, for 57 hours. It's too big, so that's why we need machines to help us do it.
Get young people to do it, and then we're actually getting them to listen to the radio.
Nice.
Then the simplest solution is always the best, isn't it, Paul? Absolutely right. Okay. Humans, unfortunately, can't quite do this at scale. We need some machines. So let's just come back to our Jeremy Vine episode. And for the final part of this, we have segmented it, we've transcribed it, and now we're feeding all of these transcripts through our entity extraction engine, which is one of those kinds of words that appears to the side of you when you say it. And every single segment now will be tagged. We can say what each individual one is about. This is not a whole program level. This is every single segment within a 2-hour show. We can say what this is about. So as a reminder, what we started with, before we pumped this content through Fenchurch, we have 8 or 9 words that tell you what this thing is about. And if you were here listening to Dino earlier, then you kind of get why this can happen, because the production teams have 1,001 other things to do that do not necessarily involve capturing lots of valuable metadata so that we can pick it up and do stuff with it. Right? We have a really limited description, but we're doing this process in real time. So 7 or 8 minutes after the program is finished, we convert 8 or 9 words into a magical word cloud of metadata that we can use to drive some real value in our products. And Chris will tell you how it actually works.
So as you can see, it's entirely magic. No, it's not magic. So one of the things we needed to do to make sure this started happening fast is making use of all the systems we already have. So in particular, we're using our studio playout and recording machines, particularly the now playing feed, so we know when they play a pre-recorded item, but also when a mic fader is opened, we have an automatic recorder that starts recording, and that's where we capture our speech segments for when they're in the studio. Both of those things get punted off into the wonderful world of the cloud, where a piece of serverless code, in our case an AWS Lambda function, picks apart that notification, figures out whether it's something we care about, which sometimes it won't be, and then kicks off a step function, which is basically a kind of step, a lambda function kind of thing, which allows us to do a bunch more other stuff. So in particular, the first thing we do is we record the fact that a segment has happened, and we do that in our own running orders database, which is something we've built. That gets kicked off by a Lambda, and then there's a service that backs it, which has an API. I'll come back to that in a second. We also send that off into 2 different BBC platform products. One is speech to text, which does speech to text, but it can run a number of different engines. And then we've also got the content enrichment chassis, which is quite similar to speech to text in that you put something into it and you get enrichments out of it. So the way that we present ourselves to the rest of the company is we have a service called the Running Orders Service. It has an HTTP API. You can come to it just the same as any other API and say, please tell me what the structure of the program is. And you will get back a structured data which will describe how all of the segments landed within a single program. Also, we can generate notifications, so if the program is in progress, you can get notifications as new segments get added to the program. And these are pretty standard APIs that services tend to use these days, and all based on internet technology, nothing special. So one of the kind of special things that we have is a product called speech to text, which allows us to get a bit of audio, send it off to this internal product, and then we get a transcript back in a standard format. However, in the background, it can use any number of different speech-to-text engines. So, for example, you can use AWS Transcribe, which is what we're mostly using at the moment. But there's also the possibility of integrating any number of things, so Speechmatics, for example. Also, we have a BBC version of the Cowdy speech-to-text engine, which is trained on our content and being developed by R&D. All of those transcripts will come back and be given to us in a standard format, so we don't actually have to know which engine created it. And then as more and more people use this across the BBC, so TV and other things, we'll be able to make best use of the best engines for the best purposes and get the best value of money, and we can swap them around very quickly depending on if performance improves in one versus another, for example. Almost exactly the same diagram for the segment enrichment. In this case, we have some text that we pump into it, and we get some basically tags come out of it. The back-end part of this at the moment, we've got potentially a number of different back-ends. Two of them are actually developed by R&D, so this is Starfruit and Mango. These have been trained using the BBC News website, and basically taking the tags that have been generated by journalists and then attaching that to the text of an article. That trains a machine learning neural network, which then spits out tags when you put an arbitrary bit of text into it, which is quite cool. Mango is a similar kind of thing, but with a slightly different focus. However, we don't have to use those. We can also use commercial ones as well if we want to. All of the results from that comes back, and then we can stash them in our own service or pass them on to other people as we need to. So what can we do at the end of this? Because we've done a bunch of work, and it's all using kind of reusable architecture and infrastructure. So we can automatically tag programs at basically live. We can give people access to transcripts, which enables them to, well, first of all, get the transcripts from their programs, which is pretty handy, even if it's not 100% accurate. We can also help people search for the content. So if they remember talked about, chihuahuas last Thursday in their program, then we can probably point them towards the bit where they did that. Also, this helps us in terms of recommending and understanding what each segment of program is about, so we can point people in the right direction for the content they're interested in, and indeed find out what content has performed the best as well. And generally that gives us the advantage of enhancing recommendations and indeed kind of user journeys for the audience, as well as the internal audience as well. Overall, oh, and I should also mention that this is happening like literally right now. We're transcribing all of Radio 2 currently, and we have been for the last few weeks, or a couple of months now, actually. And because most of it's cloud-based, we can, with a bit of jiggery-pokery, plug it into other networks and just suddenly start doing it with very little effort, and things will just scale up automatically, and we don't have to worry about just running loads of servers and all that kind of stuff. So it's really flexible, and we can add to it and improve it over time really easily at scale. And that's pretty much it. Thank you.